Saxon Advanced Mathematics, lesson 98. I've called this one Supersonic Logarithms because we're going to do some crazy stuff with our buddies, the logarithms. I will explain, let me just do a quickie review before we get into the first one. I want you to remember that logarithms are a very simple idea. They're closely related to exponents. In fact, log is just another word for exponent. And if I show you this, it probably doesn't freak you out at all, right? 10 to the third power is 1,000. You know that. That's comfortable. That's easy. When we write logs, we're just writing this same information in a different style. Here we say that 10 to the third power equals 1,000. 10 to the third power equals 1,000. It's the same information. The exponent that we put on the base of 10 to get 1,000 equals 3. We call this number the base. And we call this number, I like to call it the number, but the mathy word for it is the antilog. And then this number we can call the exponent, or it can be called the logarithm. And notice that all of these same numbers are present in our exponential equation, right? That's what this is called. This is called it's not going to fit. This is an exponential equation. And this is called a log equation. And, okay, so this is the base and this is the exponent and this is the number, right? They all appear in both equations, just in a slightly different order. But I find if my head starts to spin when I'm in log world, I just stop and think about what is happening if I think of this as an exponent. In the problems that we're going to work, we're going to be doing some backing and forthing between the two different forms. So buckle in and be ready for that. Let's start with the first type of problem. They're change of base problems. And this is just a fun little thing. Okay, John asks us to find log 5/15. The base is 5. We want to know what exponent do we put on 5 to get 15. We don't have a log 5 button on our calculator, so we would need tables to do that. And you know what? We're not going to go digging out any freaking tables. So we have to find another approach. First thing we're going to do is make an equation out of this. That'll be the easiest thing you did all day long. You just write, let's choose y. Y equals log 5/15. Now, that looks a little weird. We're used to seeing this part on the left and the plain thing on the right. Okay, so let's just write it the other way. Log 5/15 equals y. Y is the exponent that we put on the base of 5 to get 15. Okay, that's making sense to me. It looks a little more like something we can handle, but we still don't have a base of 5. So what we do now is number 2, change to exponential form. Just like we can toggle back and forth between these two forms here, we can rewrite this. The base is 5, the exponent is y, and that equals the number. Oh, this is perfectly reasonable, right? Cool. Now we are getting closer to the answer, even though it might not look like it to you yet. Now the third thing that we do is we're going to take the log of both sides. We now get to choose what log we take, And I personally always prefer to use the common log, the base of 10, right? The base of e is in our calculators. It's just as easy to use, but I like to avoid that extra layer of having a letter in my problems. So we're gonna take the log of 10. Remember that the common log, we don't have to write the 10 there. If we just write the word log, then we know there's an invisible 10 hanging out there. So now I've got log of 5 to the y equals log 15. Now my calculator can handle these, all right? But we're almost there. We just have to do a little algebra and then we're ready for our calculators. So let me copy this to the top of the next page. Okay, so now we're going to use, what number am I on? Number 4. We're going to use the power rule that allows us to take an exponent and plop it down as a coefficient, right? So this is the power rule. It's the power law for logarithms, technically, right? Remember that the rules for exponents and the laws of logarithms are the same thing, just in slightly different formatting. So we're going to use the power rule to bring that down. That will give us y times the log of 5 equals the log of 15. And then we're going to simplify this by dividing both sides by log of 5. That cancels, and then we are calculator ready. And we say y equals the log of 15 over the log of 5. We recognize right here that we better set a parameter somewhere in here that the log of 5 can never be equal to 0, right? Better just make sure we cover that. But now we're ready in our calculator. You can't divide these and say it's the log of 3. You have to find the log of 15 and then divide it by the log of 5. And what you will get is that y equals 1.6826. And if you go all the way back to the beginning of the problem where we had this, we can say that this expression with the log of the base of 5 that we said, how are we going to figure that out? We do not have a log 5 button on our calculator and we're sure not digging out tables. We did it. We turned it into exponential and then we took a common log of it and we got the answer, 1.6826. Yay, right? So the moral of the story is we can do a lot of crazy stuff with these logarithms and that's what this lesson's all about. All right. Let's try another one. Because that was so fun. I find these strangely entertaining. Find log 7 of 82. This is the base. We don't have log 7 buttons on our calculator. We're not going to get out the tables. So we follow the same steps. First, we turn this into an equation. Y equals log 782. Then we're going to rewrite it so it looks the way we're used to seeing it. Log 782 equals y. Then we're going to write it as an exponential. Okay, so this is the base and that's the exponent. So 7 to the y equals 82, right? 7 to the y equals 82, that's right. Now we're going to take the log of both sides. We could take the natural log. I like to take the common log. Log of 7 to the y equals log of 82. We use the power rule to pop that down. We get y times the log of 7 equals the log of 82. And then we're going to divide away that log of 7 to get y by itself. Right, that all cancels. And now we're ready to go to the calculator. Remember, you can't divide 82 by 7. You have to find the log of 82 and then divide it by the log of 7 using the common log buttons, right? The base of 10. And we get an answer that says y equals 2.2646. And then we put that back in the context of our original question, and we can say the log of 82 with a base of 7 equals 2.2646. So what that means is 7 to the that equals 82. And that makes sense because 7 squared is 49. 7 to the third (28, 34). Okay, so 7 to the third equals that. 7 squared equals that. This number is in between those two, so it makes sense that the exponent is also in between 2 and 3. So this is our final answer. So our answers aren't total gibberish. Let's look at this one. The exponent that you put on 5 to get 15 is this. Okay, well, 5 to the first power equals 5, and 5 squared equals 25. 15 is in between 5 and 25, so it makes sense that our exponent is in between 1 and 2. Yay! Even better when it makes sense, right? Okay, so those two problems had to do with changing the bases that we were using in the log problems so that we could do the calculations on our calculators and not have to dig out the old log tables. Or slide rules. I think slide rules would work too, but we're not going to do that. All right, now we're moving into a different category of problems. There are 4 of them. And each one of them kind of has its own little crazy tricks and flourishes. So these are, John calls these contrived log problems, meaning they are not necessarily real world. He's just come up with some crazy ways to let us practice our mad log skills, which I'm excited to do. You guys, what is wrong with me? I'm a person who thinks this is actually really fun. So I'm sorry. All right, ready? Solve. Log of x squared equals the log of x squared. Oh, Okay, so what can we do with this? Well, they're subtly different, aren't they? This is what we're used to seeing, and this is the kind where we can use the power rule to pop it down. So we're gonna do, that's gonna be the first thing we do, is we're gonna use the power rule, but it's on the left side only. This is not the power rule in the making. This is. So we're going to write 2 log of x equals log of x squared. All right. Now, we don't really have a good way to simplify this. It would be log of x times log of x. So what we're going to do is we're going to get these guys on the same side. So let's subtract this. It's going to be 0 equals log of x squared minus 2 log of x. I would like to write that in the other order because this looks weird to me. So I'm going to write log of x squared minus 2 log of x equals 0. Now, it's kind of hard to see it at first, but what we can do if we simplify this, this is kind of like x squared minus 2x equals 0. How, right? If you just ignore the logs, it's the form of it is just like this. How could we factor this? Well, we could pull an x out of both sides, right? I should have made that bigger. right? That's how we would factor this. We would just say, okay, well, let's pull out the x. That's all there is. So that's what we're going to do here. We're going to factor out log of x. Remember that when we say log of x squared, that means this is log of x times log of x, right? That's what it means to be squared. So we're going to factor one of those out. And that will leave us with one more. And then when we factor out of this, we'll just have the minus 2. Wow. That was kind of crazy, right? So now, just as we would factor here, we say either, this is called using the zero product theorem, which is a fancy name. But remember, all it means is that if we're multiplying two things together and they equal 0, then one or the other of them has to equal 0. So either log of x equals 0 or log of x minus 2 equals 0. All right? What is the exponent? There's an invisible 10 here. We can evaluate this by looking at it as an exponential, right? 10 is the base, 0 is the exponent, x is the value of 10 to the 0 power. That means x equals 1, right? Anything raised to the 0 power equals 1. So we've simplified on this side, and there's one of our answers. And now over here we say log of x equals 2, and then let's switch this to an exponential. Remember, this is a 10, so this is asking us 10 squared, and that means that x equals 100, and those are our two answers. What the actual heck? That turned into something weirdly easy at the end. We had to kind of go through this crazy journey through the forest to try to figure out how we could rearrange this. But if we just follow our old school factoring instincts, it got us to where we needed to be. That was weird, wasn't it? Keep in your mind these patterns so that when problems like these come up in your homework, because they probably will come up in the very same structure, you can refer back to these problems and remember how to do them. Okay, let's do another one. 98.4. All right, in this one, we're supposed to solve something that looks like this. It's kind of like John just sat up late one night and made up weird things for us to deal with. All right, fine. One thing I know for sure is we don't want pig houses. We want fractional exponents. Pig houses are cute, but you know what? Fractional exponents are way easy to deal with. So how would we rewrite this? This, we would just have basic like that. But this one, we would have to put log x in parentheses and then put the 1/2 on the whole thing. Subtle difference, right? The way those pig houses are displayed. This one, we can power rule and pop him off over here. So this turns into 1/2 log of x equals, whoops, log of x to the 1/2. Now, I really want to get rid of that. And the best way to do that is to raise this whole thing to the second power. These will multiply together. It becomes a 1, and it goes completely away. So this just becomes log of x. But of course, we have to do it over here. We have to square that. And now this becomes, we're squaring it. Why did I write it over there? We're squaring it. 1/2 squared is 1/4. And then it is like so. All right, that's the way this looks when it's squared. That's kind of weird. Now let's do what we did last time. Let's bring them to the same side and see if we can factor anything. So let's bring him over this way. So 1/4 log of x squared. So we remember this is log of x times log of x, right? Minus log of x equals 0. What can we factor out? We can factor out 1 of the log of x's, right? So it will be log of x times 1/4 and the other log of x minus 1, right? Because we pulled that whole thing out, equals 0. If you ever get turned around in this factoring, just go to the side and write it as if it wasn't a log. Like I could take this and I could say, okay, what if I just do 1/4 x squared minus x, right? Okay, I can pull an x out of both, and I'm left with 1/4 x minus 1, okay? Do it on the side without the logs in it if you need to kind of calm your brain down and figure out what the heck you're doing. All right, so now we're at zero product theorem time. So either log of x equals 0 or 1/4 log of x minus 1 equals 0. This is ready to go to exponential. This means 10 to the 0 equals x. And so that tells us that x equals 1. Oh, we got that answer before, didn't we? And now this one, let's swim the 1 across, and then we're going to have to multiply both sides by 4 over 1 if you like, to cancel out that fraction. So this all cancels. We get log of x equals 4, and that tells us that 10 to the 4th equals x, right? Because there's an invisible 10 here. 10 is the base, 4 is the exponent, x is the number that you get, and that tells us that x equals a 1 with 4 zeros, and that is 10,000. 2 strangely simple answers. Considering what we started with, who would have ever known it would work out to that, right? Okay. What else can you cook up for us, John? I'm thinking about what I can tell you about how to know how to begin these. And I guess what I would say is look for the most annoying thing. These pig houses were annoying. So then we changed them to fractional exponents. And then I wanted to get rid of the fractional exponents. So I did what I could with those. So I think that the most useful thing for you to do is when you're starting these problems, refer to the notes and examples so that you can find a toehold. But after a while, you'll just kind of remember, oh yeah, this is annoying, that's annoying, right? Just kind of follow your path of irritation. Okay, here comes another one. (98.5) solve. Well, that looks weird, doesn't it? We don't usually have a log of a log, but if we think about it, okay, well, there's the base, and this is the number, and that's the exponent. So we can easily rewrite this as an exponential. We can write that 10 to the 3rd power equals the log of x. And then I like it better if it's the other way around. So I'm going to write the log of x equals, and then I'm going to write this number out rather than having an exponent. Oh, okay. So what this means, I'm going to put my base in. This is the exponent that goes on that base, so x equals 10 to the 1,000. I don't think I'll write that out, but this is our answer. Oh, wasn't that strangely quick and easy? We went from here, I just flipped the side so it was easier to see, but then we changed it to an exponential, and then changed, that became another log equation, right? And then we changed it again to an exponential. Strangely quick and satisfying. All right, and one more. This is an x, it is the base. The exponent is the square root of the log of x. Do you feel like you're in a bad dream? I kind of do. Equals 10 to the 8th. So what the actual heck are we going to do with this? This is written in exponential form. So what we can do is take the log of both sides. What? This is exponential, right? There's a log up here, but there's no logs down here. So we're going to take the log of both sides. The log of x to that monstrous being equals the log of 10 to the 8th. All right, let's pop our exponents down. Let's use the power rule. So this will come out here, and this will come out here. Okay. That's fairly insane, right? Now, we can simplify the right side pretty easily because the log of 10 with base 10 means 10 to the x equals 10, and we know that x equals 1. So the log of 10 always equals 1. Okay, that's like an identity log. So this drops away to just 1. So that means the right side is 8. And I want to change this to a fractional exponent. So it's going to be log x to the 1/2 times, and I'm going to put this, I'm going to 1 because I know I need to combine the exponents. So that just helps me, equals 8. Okay, when I'm multiplying matching bases and they match, I can add the exponents. So that'll become, I can make this 2 over 2, right, to make my life easier. So I can write log of x to the 3/2 equals 8, right? Because this whole log 10 thing disappeared. Now I can pull this down. Do you feel like you're just running in circles? Three halves log of x. Well, John did something different. John didn't do this. He didn't pop it down. What John did is at this point, he raised it to the 2/3 power, and then he raised this to the 2/3 power. I like that. Let's do it that way. That turns this into a 1, and we just get log of x. 8 to the 2/3 means take the cube root, which is 2, and then square it, which is 4. This says put the exponent of 4 on the base of 10. 10 to the 4th equals x. That's the number, right? And so x equals a 1 with 4 zeros, which is 10,000. Dang, we did it again. Those problems are gold standard logarithm problems. I don't think we're going to get much harder than that. Those are very complex, challenging problems. If you could even follow along with those, congratulations. That's really great. Use your notes to help you as needed for your homework. Yay. Fantastic. Again, like I said, If you feel like you're swirling but you sort of followed it, that's good enough for me. Lesson 98 is done. Thank you, goodbye.